Hello. My name is Petr Jelínek. I work at Second Quadrant, and I want to talk a bit about logical replication in Postgres with focus on a tool that I'm developing that's called PGLogical. First, a bit about me. As I said, I work in Second Quadrant as Postgres developer and consultant. I developed quite a few patches over last decade for Postgres. And I also, in my free time, co-maintain pgbench and some other technologies related to Postgres. You can mail me or find me on GitHub. I don't really do social network much, so. About today's topic. Logical replication. Why do we want logical replication in the first place? Postgres already has something for replicating data. It's the physical streaming replication that basically synchronizes the data in real time to a different server or different virtual machine or whatever you want. But it has some limitations because the way it works is that it basically creates exact bit copy of the master on your standby machine, and that brings limitations like the nodes have to be exactly the same. You can't create additional indexes, tables. You can't have different security access defined. You can't do any kind of data transformations on this, and you can't replicate cross-version because Postgres can only read the data of the same version that produced it. So what we want is something that lifts these limitations, right? You sometimes want to replicate just part of your database, or you sometimes want to replicate multiple databases into single target, or you want to do online upgrades. You want to sometimes have the data replicated to analytical database so that you can add more indexes so that your queries are faster there. You want to create temp tables, things like that. So that's why we actually started doing this logical replication thing, and why you should actually want the logical replication. So before I go into details, let me start with some history about how logical replication in Postgres evolved very quickly. So logical replication is obviously not a new concept, not in database world and not even in Postgresql world. There are solutions that existed for more than a decade, like Lundiste or Slony, but those are all trigger-based, which brings many limitations with that as well. You have some external application that has to run outside of Postgres. You have to monitor it separately. You have to make sure that it starts correctly when the PostgreSQL restarts and things like that. It also has to write everything into its own queue, which means that everything you write on your master, you will write again into the queue, which then means that your I/O doubles basically. And since they usually use tables as a queues, it means that your write-ahead log also doubles because you have to write everything into your table and then into the queue table. So, but they work reasonably fine. But again, lots of limitations. The other problem with specifically these two that I mentioned, the Lundiste and Slony, is that they are not really well maintained anymore. The last feature release of each of these was several years ago, so that's for me personally a bit worrying as well. So we in Second Quadrant started thinking about doing something about this and bringing something better and more integrated and eventually get it into Postgres itself. I assume that everybody was at the keynote where Simon talked about Postgres BDR, so all this that I will talk about actually has roots in that same project. As I said, or as Simon actually said, that currently runs on 9.4 with 9.6 coming soon, and it does a bit more than just logical replication. It does multi-master with transparent DDL and stuff like that, but that's not the topic of this talk. The topic of this talk is mostly PGLogical, which is basically a simplified version of that. which doesn't require any kind of patching of Postgres. It's just simple extension that you just install and it will into Postgres and it will work directly from there. It works on anything on 9.4 and higher. Its main purpose is to do one-way replication, not multi-master, although it can actually replicate in bidirectional manner. That can be done, but that's not the main reason why it exists. And the main goal for this was to replace trigger-based solutions like the long-distance learning, and also to serve as a base or code base for what will be in Postgresql core as a replication solution. So a bit about architecture. The architecture of this is basically evolution of this physical streaming replication. So when you do physical streaming replication, you basically have some applications that can write to your master database where there is executor that executes the SQL statements and then reads and writes from heap and also writes to the transactional log. The writes from the transactional log are then read by something that we call wall sender. That's a special process that runs within your PostgreSQL instance. And this process sends it to another machine standby where there is opposite receiver that then writes it into write-ahead log. And from this write-ahead log, the data are synced back to the database, and then executor can read from there. And that's a relatively simple process, and that's how current replication in Postgres works. The logical replication basically builds on top of this by adding some additional APIs into this sender process which do two things. One thing is that it decodes the transactional log from binary data, like change these bits in this file into these bits, to actual logical changes, which means change this row in this table to these values. And then it exports some API, like low-level C API, which can be used by something that's called output plugin to generate its own data stream based on these logical changes. And that's the base technology behind the logical replication. Then obviously you want to implement some remote side that can read this stream of changes and apply them to the database. The apply side both in PGLogical and whatever will be in PostgreSQL 10 just runs some apply process that looks mostly like another client to your Postgres database, except that it uses low-level APIs to achieve better performance in writing. And then, since this basically writes not just the transaction log, but writes directly the changes to the database, this subscriber database can then be just normal Postgres instance, which doesn't really have any other limitations. It can be master for another standby for physical replica. It can be provider for another logical subscriber. You can do writes on it. You can have different structures on it and things like that. So it's just basically moving the logical changes and not the physical ones. So what PGLogical does is basically implements this API that I was talking about and the worker on the other side. And that's all the magic there is. Rest of it is standard Postgres streaming replication architecture, unmodified basically. So the goals for the project of PGLogical was to provide a selective replication so that you can replicate just part of your database. B, way to do online upgrades, so replicating between different major versions of Postgres, mainly from lower version to higher version, even though the other way is also supported, but it's not the main goal of that. And also have some kind of basic data transformations and basically allow you to do data integrations, stream multiple databases into single database, or have shared few tables where you have one write master, and then for few tables, like configuration tables that are shared across many databases, and then you replicate those few tables from single point to all the databases, and then you can ensure that everything is synchronized without having to do it in application and things like that. What we also wanted to have, and that's something that the other logical replication solutions don't have, is support for synchronous apply, so that you can do synchronous replication if you need to. And that's one of the reasons why it all works very similar as physical replication, because we built it on top of the same architecture as physical replication, we get this optional synchronous replication for free. And it works same way as in normal physical replication, so it's per transaction, you can specify which nodes should be synchronous and stuff like that. We also wanted to have simple installation. There was some talks about that. So it just installs this extension, runs as part of Postgres. All of the configuration is inside the database. There are no config files that would tell you where all the nodes are and stuff like that. All is Postgres tables. And it starts automatically with Postgres. It shuts down automatically with Postgres. It's monitored via SQL from within Postgres. There is no external stuff needed. It uses something that we call logical decoding, which is the API that I described quickly, where it reads the transaction log and changes it into logical changes. This feature was added in Postgres 9.4, which is why we only work on 9.4 and higher. And also it executes triggers if you set enabled as a replica. Which means that you can have some simple data transformations on the subscriber side this way, because the data actually will go to the trigger, and the trigger can do some changes to it. It has some limitations that I will talk a bit about, but the basic transformations or basic triggers work. Obviously, it doesn't trigger normal triggers. Like if you just create normal trigger, then it's not triggered, because that would mean that if you had some post-processing in your insert and then it would replicate, then you would get the post-processing again, which is not wanted. But there is like special type of triggers that you can mark as enabled replica via auto trigger, and those will be normally executed. It's very similar if you ever used Slowney or Londista, they do the same thing basically. So how do you use this thing? As I said, you just install extension. You also need to load it via PostgreSQL config, but the basic operation is that you install extension, you define something that we call node. Node is something that is basically name and connection string. The connection string that you specify here is the connection string to that node. So the my provider node, in this case, on the provider, should listen on the host 10.10.11, and you should execute this in the database foo, basically. And then on subscriber, you again create the subscriber node, and then create subscription where you name the subscription and specify from where it should replicate. The reason why you specify connection strings here is that the initial data synchronization that can happen then for the tables, or even not just the initial one, but if you add tables later, the synchronization needs to know connections to the node itself. So basically the subscriber needs to connect to itself to be able to actually copy the data. And since Postgres doesn't internally provide any kind of API to get local connection string, you have to provide it as a user. So that's why we actually require you to provide the connection string. The subscription name is quite important for monitoring later, because that's what application name will be visible in the pgstat replication, and that's what you specify in synchronous standby names if you want synchronous replication and things like that. So the subscription thing is very important for monitoring. You should always have different name for each subscription. So how do we achieve this selective replication is something that we call replication sets, which is a term that we borrowed from Slony, I believe. And replication set is basically just group that defines tables, or that group of tables that define the replication itself. It doesn't have any special meaning. It's basically just named group so that you can have different subsets of tables that you replicate to different places. Nothing else. Important thing to note is that unlike with physical replication, this doesn't replicate anything until you actually add it to the replication set. And if you define some table into 3 replication sets and then you subscribe with some subscription to all those 3 replication sets, you don't have to worry about data being received multiple times. The replication sets are, like the replication still happens on the table level. The replication set is really used just as a grouping. And then union of those groups are taken for replication. So each change always travels only once. We also provide some filtering on this replication set level. You can filter by operation. So you can say that by default, all those replication sets replicate everything, but you can specify that the specific replication set shouldn't replicate, for example, deletes, which can be useful, for example, if you want to roll up your data into data warehouse or OLAP database and you want to be able to delete your operational data in your transactional database, but don't want those deletes to propagate to your OLAP database, then you just say don't replicate deletes, and it will just skip the deletes and replicate only inserts and updates, and you will have all your historical data and can remove the new data if you want to. Yes? Sure.
It's really interesting. So for the target database, can we create table? So let's say I want to group the tables, but reference tables to a different database. But let's say I create schema for this group of tables. Can I also create other schemas for other purposes? Can I create tables? So basically, for the target database, is it just read only, or would you say?
So the question is if the target database can have different tables than the ones that are replicated. Yes, you can. You can have additional tables. You can have. You can even have additional columns in the tables that you are replicating and things like that. So yes, you definitely can have additional schemas.
And for those additional schemas, it can be writable.
Yes, even the replicated tables are still writable. So what happens is that we don't actually limit you in terms of like what's writable. Even if you replicate the table to different node, on that different node, this table will still be writable. And PGLogical actually has mechanism to detect if the change was made locally or was made by replication. And then if the local change conflicts with what's coming from replication, there are some conflict resolution methods that you can specify via configuration. I don't talk about that much here, but there is like, you can say that by default, it basically, the replication always wins. So if replication conflicts with the local changes, the changes from replication will always be applied. But there is possible to configure it in a way that local changes always win, or that the replication stops on conflict and it's left for user to resolve it, or that we will pick the latest change by commit timestamp. And so you can choose this, even if you write locally, that how it will behave when it detects some writes that are not compatible with what's coming from replication. Okay, so back to the filtering. There are some predefined replication sets, default insert only, and DDL SQL. DDL SQL I will talk about when I speak about DDL replication, but the default is basically just replication set that replicates everything. That's just predefined for you. It doesn't have any really special meaning. The default insert only is replication set that filters updates and deletes and only does inserts and truncates. The reason for adding the insert only replication set as a predefined one is that in current version of PGLogical, the limitation is that if you want to replicate updates or deletes, your table has to have primary key, because we only are able to look up the rows by primary key or unique index, which is the same thing with not null, obviously. So we provide this replication set for insert-only tables that don't have primary key. You can put it in this replication set and they will still replicate. Just the inserts and truncates. So how do you add table to actual replication? We provide interface that's called replication set add table. You provide the name of the set, you provide the name of the relation, and you specify if all the subscribers should immediately synchronize the data or not. It's also possible to resynchronize the table later. There is from the individual subscribers. So for example, if you already have the data for the table on some subscribers, you would say that you don't want to synchronize everything immediately and then would resynchronize on every subscriber as you need to via a separate interface. One thing is that unlike the initial synchronization of the data, here when you add the table afterwards, like the synchronization works slightly different depending if you defined the replication sets before you subscribe or after you subscribe. If you have some replication sets defined before you subscribe, we can synchronize the structure for you as well. If you add the tables later, we can't synchronize the structure yet. So you have to have the table actually already existing on the subscriber if you want it to be replicated. That's some limitation that will probably not exist for long, but for now it's still there. We also support replication of sequences, which has similar interface, except that it's not called replication set add table, but replication set add sequence. You just add sequence there, and that's it. They are replicated somewhat differently than tables, though, because this infrastructure in Postgres that's called logical decoding doesn't support decoding of sequence changes. So we had to invent a bit different way of doing that. We are doing it very similarly to what Londista does, for example. So we basically read all the sequences that are replicated, say, okay, this sequence is changing at this rate, so we should tell the subscriber to be this much in front so that it never falls behind the master, and that's it. So then you get some interesting artifacts for this, and that is basically that subscriber is basically always in front of the provider in terms of the last value of the sequence. So the provider can have value something like 1002, while the subscriber has already something like 2000. Yes, there was a question.
In case of using the cache value, what is the procedure?
Cache value doesn't really play into this. We work on the bit lower level than that. So we just care about the last value. If you cached more, the algorithm is like dynamic. So if we detect that you are consuming the sequence very fast, we will increase the buffer, and we will also increase the rate at which we update. If you are not updating very fast, we will make smaller buffer and update slower. So like cache value doesn't really play into this at all. You can use whatever you want there. Yes, also.
So you said also can do data transformation.
Via triggers. You basically have triggers on the subscriber, and then you can transform the data as they are incoming. So you define insert trigger that's replica enabled, and then if insert comes, the trigger will be executed, and you can do something with that. There are caveats with that, and so the thing is that obviously if you, for example, if your insert trigger, for example, inserts to completely different table, and thus like it's like instead of trigger or before trigger that returns null, then you will have no data in the target table. So if the update comes, the update doesn't find any row, and then the update trigger will not be executed. So there are some caveats with this. It's something that we actually want to eventually provide some custom triggers that would be like not Postgres trigger, but that you would specify a function that's supposed to be called on incoming data, and then you can like do the transformations on updates as well, but currently the transformations are limited mostly to inserts, because if you like move the data somewhere else, then the updates will not work properly. How do you monitor this? Since it's based on the streaming replication, it's basically the same as monitoring the physical replication, meaning that pg-stat replication view and has the values of how far the subscriber is, what's its name, and all this information that you would normally expect for physical replication. The good part about this is that if you have monitoring solution that supports physical replication, it doesn't really need any changes to support this as well. You will automatically see the PGLogical replication there as well. There is one thing to note, is that with logical replication in general, you always want to monitor your replication slots, and that even if you use replication slots with physical replication, you should always monitor them, because the replication slots will keep your transaction log forever if you disconnect your subscriber. And that's true for physical replication as well as logical one, which means that your disk will eventually run out of space if your replication is not happening and you still have defined the slot. So you should always remember to monitor the replication slots if you are using them. And logical replication always uses them. We also provide some additional monitoring functions. We have show subscription status, which basically shows the status of the replication worker on the subscriber, meaning that it shows that if it's running, what stage it is in information like that. It's very similar to the WAL receiver status that's in 9.6, I believe. And also we provide an additional information about the status of the initial copy of the tables that you added to the replication, because the initial data copy can run for a while, so there is sense to monitor what state they are in. Basically, you can see that the table is either being created or being synchronized in the terms of data, or that the constraints are being created, or that it's catching up with the main worker, or that it's ready and replicated. There was another question?
The table at the later stage of having the data on the front side.
Mm-hmm.
Then is there any lag for getting the data on the other side? It won't be similar to the synchronous, right?
So the question is how it behaves when you add the table when the replication is already running. Yeah. So we basically use copy, standard Postgres copy. We copy from from the provider to the subscriber. We create basically a snapshot from which we copy the data. That's run in single transaction, so you see it once it's copied, and then the table is being synchronized with the rest of the replication. And once that happens, the main replication takes over. So yes, it's not completely consistent while it's being added. That's why we actually added this monitoring function, because this monitoring function will show you all the steps that happen. And once this monitoring function, the show subscription table, says synchronized, it means that it's synchronized with the rest of the replication stream, and all the data are like transactionally and isolation-wise consistent with the rest of the database.
So we can use that status for verifying that.
Yes. Yes. Exactly. Okay, so next thing is DDL replication, and here we are slowly getting to caveats. We don't do transparent DDL of replication of like what you execute will be automatically synchronized. BDR does that, but PGLogical doesn't do that yet. We can synchronize the initial schema if you choose to, but we can only synchronize the whole schema or nothing. Again, that's current limitation that probably will be lifted at some point, but that's how it is. We provide though a function where you can say, replicate me this statement to all the subscribers or specific subscribers, and that basically you just use this as if you want to create table or alter table, you just wrap that command into this function, and it will just execute it locally and put it into replication stream, so it's executed at the right moment remotely as well. And this is where the DDL SQL replication set predefined one comes into play, because it's the default one that will be used. The reason there is when you are subscribing to provider, you can specify what replication sets you want to subscribe, right? So if you have some DDL statement that should only affect some subscribers, you can specify that this replication statement should only affect these replication sets, and only the subscribers that are subscribed to those sets will execute that statement, and the other subscribers will just ignore it. So we basically allow you to filter the DDL statements manually, or kinda manually, if you want to. That's it about DDL replication, I guess. There is one limitation again for this, and that's create index concurrently, because in PostgreSQL, create index concurrently cannot run inside transaction. And again, in PostgreSQL, if you execute function, you are always inside transaction. So you can't basically use the create index concurrently with this function, and you need to execute it manually if you want to run it. A bit about performance. This is just standard pgbench on some AWS machine that my colleague did. It shows the comparison of some standard pgbench run between streaming replication, PGLogical, Slowly, and Londist. We are about 5 times faster than the trigger-based replication solutions, but we are a bit slower than streaming replication, although this is very dependent on your access pattern, mainly the write patterns, because if you have a lot of updates and a lot of vacuum, or if you do in general a lot of write-ahead log writing, like you have many indexes and things like that, we can be actually faster than streaming replication, because we don't actually replicate all the bloat that you generate, because we only replicate the changes to the tables. So there are use cases where we are actually faster than the physical replication with the PGLogical. There are also use cases where we are much slower than what's shown there, which is, for example, if you have really, really large transactions that change millions of rows. Yes?
Back to the previous slide, I noticed that basically went flat at 16 workers, is it?
Yeah. I think that's artifact of the benchmark, to be honest.
Okay, so do you think that's a PGbench thing?
Yeah, because you can also see that there is like maximum of 10,000 TPS or something like that, or 8 actually. I do have custom benchmarks that do 5 times of that, so I think it's actually an artifact of the benchmark. I actually didn't do this benchmark myself, so I'm not really sure why it is like that, but we definitely can do more transactions than what's actually shown here. Again, this really depends a lot on your workload. The main purpose of this was to verify that we are faster than the trigger-based replication mechanisms, to be honest. But yeah, to the caveats where we are really slow is when you have big transaction that changes a lot of rows, because most of the logical, or all of the logical replication solutions that I know of, and not just in Postgres but in other databases as well, are transactional based, meaning that they will basically load one transaction, move it over to the other side, and apply the transaction. And so if you have transaction that changes million of rows, all the smaller transactions that were written behind it will have to wait for this big chunk of the data to be applied, meaning that you will have some increased lag time for the period of time when this transaction is being applied. And then that's where like the TPS can go very fast down. In terms of replication, obviously, the actual TPS on the database will not be really affected. Sadly, it still doesn't play very well with physical replication. So the problem there is that, again, logical decoding in the current releases of Postgres can't follow the promotion of the standby to master, which means you can't really use the standard HA methods with this, and you either have to manually switch the replication over to the other database. We do provide some interfaces for that. We actually allow you to change connection string from where the replication comes from and stuff like that, but it doesn't play very well automatically yet. It also means that, or the alternative is obviously to use just logical replication for HA purposes as well, but there is not that much tooling for that yet. So the failover part is slightly complicated right now. There are some patches to address this issue into Postgres 10. They were actually already for Postgres 9, but they came a bit late in the release cycle, so it didn't get in. But there are some patches in current commit fest for Postgres 10, so hopefully that will be fixed there. And the other limitation is that all the operations with PGLogical actually require super user. So if you want to create node or create subscription or add nodes, add tables to the replication set and stuff like that, you have to be super user. It's not really delegatable. Although you can obviously you can create some security defined functions and stuff like that, but you can't grant any kind of roles to the users to do this. The user that administers this has to be super user. Let me tell you also something about future. We will be releasing PGLogical 2.0 in a couple of weeks. That adds a couple of interesting features. One is column filtering, meaning that currently the table on the subscriber side has to have same columns that the provider has. It can have additional columns and then with some default values, and those will be then added as a default values, but it can't have fewer columns, because if it had fewer columns and you did the replication, we don't really know if that's by accident and you are losing data or if you actually wanted that. So what we added is another parameter to replication set at table, where you can actually specify which columns should be replicated. And then that way you can have 500 columns and only 100 of them replicated if you want to. The only column, like you can specify what columns you want. The only columns that are required are the replica identity columns, which is basically the primary key. So primary key columns have to always be replicated because of the lookups, but any other columns can be removed as you please. And the table on the subscriber then doesn't have to have the additional columns at all.
Going to add any additional overhead?
This will actually make it faster if you use it, because it removes some work for the columns that are not added.
Copying the whole table is faster than the copying?
Not really. Yeah, yes? Question? No? Yeah, okay. It is, yes. I said in the beginning that we basically use the same method as physical replication. So you just set synchronous commit, remote apply or something like that, or remote write, and it will work automatically. And it's per transaction, just same way as physical replication, so that works fine. Yes?
Would it be possible to specify just a schema with all the tables inside it?
There is interface called replication set at all tables in schema or something like that, and you can specify then actually schema arrays. Not just single. Yeah. You can also, the thing is that also the relation parameter here, it doesn't have to be name, it can be OID, so you can do actually join against PG class or something like that and execute this function on like more complex filters that you want. Yes?
Along those lines, if you're going to do this for an upgrade, is there a way to add like, everything in the whole instance?
Well, there is no interface to add all the tables. As I said, you can do join against PG class, so that way you could add everything, but you have to write the query yourself, or you can specify the list of the schemas that will also add everything. The main reason for this is those tables without primary keys, because you have to think about that a bit. If you have some tables without primary keys, what to do with them, if you add them, if you are okay with replicating just inserts, or what to do else with them. So, or if you need to add primary key maybe. So we didn't want to make it completely super easy so that you don't have to think about it at all, because you actually do. And so the other feature for the PGLogical 2.0, and that one actually adds some overhead, is row-based filtering on the provider side, where you basically specify expression, which is just similar to where clause or check constraint, where you say only replicate rows where some values in these columns equal something or are smaller than something and stuff like that. The syntax is basically of the expression itself is basically the same as what you would put inside check constraint. It has the same limitations, which means that we do allow volatile functions, but you should be careful with them. We don't allow subselects and things like that. And one thing to keep in mind is that this expression is actually evaluated during replication. So if you say only replicate rows where user ID equals current user, then the current user is your replication user, not the user that actually did the changes to the table, for example. And also, if you say replicate everything where timestamp is smaller than now, then it replicates everything, because now is when the replication happens, not when the write happened.
Question. So this is an interesting thing. So if I put a filter, it says reflect flag for true. So you only pass the data, to flag to the target, right?
Mm-hmm.
But let's see, later update the source side, update the flag to false. Does it remove the data from the target side?
No.
So it's whatever passes.
The thing is that basically only the data that match this filter will be filtered out, and if it doesn't matter if it's update or insert. So like if you do update which doesn't match this expression, the update will not be replicated at all. So and only the rows that are affected and match this expression will be updated. And so the stuff that doesn't match the row filter will not be sent to the remote site at all.
So it doesn't do logical things. It just read it from the transaction log file.
This is all based on the transaction log file. So and this is executed only on the provider. So if you wanted to do more complex filtering, you would have to do it on the subscriber using those triggers. That's still possible, but a lot of people want to replicate small part of table. That at least our customers, we have quite a few of those that want to just replicate small part of the table and don't want to send the data over network, because network is the limiting factor. So they want to execute that on the provider. So that's for that basically. Yes.
Can you have more than one provider for this database? Is it one-to-one?
You can have as many as you want. Okay. It's multi to multi. You can have even two between the same databases. So some other plans after 2.0, we want to add purely logical failover so that you don't have to use physical replication even for HA. We want to improve those transformations so that, because as I said, triggers have some limitations. We want to add PostgresQL support so that you can stream the changes into your sharded database, or if your sharded database is Excel, of course. We want to parallelize some of the stuff because of performance. We want to add transparent DDL replication, and obviously there is always performance improvements. I expect that the Excel stuff will happen probably in the beginning of next year. The rest we will see. And while I have a couple minutes left, I want to also talk about Postgres 10, because most of this work is basis for what we are trying to get into Postgres 10. I am currently working on a patch that basically adds some basic logical replication to in core. There will not be the row filtering and some of the advanced features that we are adding now, but the basic replication should be in Postgres 10, and that's in current commit fest. I'm working on it for past couple of months. Some people that are not here are doing reviews, the Andres Freund and Peter Eisentraut. So looks like Postgres 10 should have the basic feature built in from the start. And that's it from me. You can, if you have some questions about either BDR or PGLogical, there is mailing list. There is also some support channel at info@secondcode.com, and we have a GitHub link and some website about with the documentation and all that stuff. So if you want to check questions.
So you actually you talked about data aggregation at the beginning. How did this help the aggregation?
Well, aggregations, that was again meant as you write the aggregation yourself as a trigger. Yeah. Because there is possibility that we might add like some expressions later so that you can do the aggregations directly via PGLogical without you have to writing the code. But currently, triggers are the way.
But this is a rule by rule action, right? How do you do aggregation?
Well, that depends on what you are actually what to do, right? I mean, that really depends on the use case. More questions? Yes?
What are the intersection between BDR and PGLogical?
So BDR was the original project that like implemented all the infrastructure that's needed for this. But PGLogical, but the BDR, I mean, the thing is that the BDR itself was made for multi-master, and there are lots of assumptions there in the architecture of BDR that are specific to multi-master. But that's actually not what most people need. Most people need to move data from some parts to some parts, maybe do some transformations, maybe move data from multiple places to same place and things like that. And so we wanted to make something that is simpler than BDR, easier to maintain, easier to install, and has smaller code base and doesn't have all these assumptions in the code. And also we wanted something that can be then relatively easily put back into Postgresql. And so that's why we basically simplified BDR. So this is, you can think about this as like simplification of the initial BDR concept. Yes?
Currently, it's only has subscriber from Postgres. Is it the plan to in the future to subscribe from other system like message queue or?
So the question is about if we plan to support other targets for the replication other than Postgres. Not for PGLogical, but this logical decoding infrastructure that I talked about, that's basically basis for this on the provider side, that's pluggable. So you can have like C plugins or extensions to Postgres that transform data and send it somewhere else. And since you said about messaging systems, there is actually already a plugin called Bottled Water that sends these data to Kafka. And it uses the same infrastructure that was developed as part of BDR and part of this that's in Postgres now. And so you can use, for example, that. There is also some plugins that just spit out JSON formatted changes and stuff like that. So then you can use that for integration. So not per se by this project, but we thought about that, so we made it pluggable. So actually other people actually brought already some other integrations.
What is the behavior when Postgres, the subscriber is not responding in case of synchronous?
Sorry?
What is the behavior of provider in case subscriber is not responding, or do you have any?
This is like how the synchronous replication works. Same as with physical replication. It uses the mechanism used there is exactly the same. So we actually don't even wrote the synchronous replication code. We just reuse the one that is in Postgres because we use the same underlying architecture.
But the synchronous, like
It will wait forever, yes, unless you specify some other standbys that should be used instead. Cascading works, yeah. I think I'm out of time, so if you have more questions, then please find me at the hall or something like that.